Lesson 5.3 we studied and we started last week. Just for a quick review, because I need it for the next topic, what I am going to proceed. So first of all, let me review what we studied last week about lesson 5.3. In lesson 5.3, we did talk about that when a car takes a turn, what happens. So we said that when we want a car to take a sharp curve, for example, car is at this position at this time, this is the car, it is at this position at any time. So the velocity of the car, the direction of the car is toward the along the tangent, and we can see that it will move in this direction, where I can show you that this is V. So am I lagging?
No,
No, no, it's
the
good, good.
connection is good.
Okay,
You are
okay.
not.
So this is the direction of velocity, and uh, the car, if we want to keep it in the circular motion, I told you that we need a centripetal force. This centripetal force will be toward the center of the curve, and this centripetal force Fc will be provided by friction that was named as static friction. So if this friction is provided by the between the tire and road is present, so this car, rather to move here or rather to move towards the center, it will continue its circular path, and its circular path will be in this direction, and it will move. So what are these values for centripetal force? We know that the relation of the centripetal force was mv squared over r. This was our relation of centripetal force. Secondly, we said that this static friction Fs was equal to mu s times Fn. And I told you, when car is on a straight road, for example, this is flat road like this is the road, and the car is moving above that road. This, let's say this is the car, and car is moving on a flat road. So if road is flat and car is moving on a flat road, so you can say that this car on a flat road, its Fn will be equal to mg, because you know that mg, the weight, is always acting downward direction, and the normal reaction according to Newton's third law, action and reaction are equal and opposite. So this normal reaction is upward, this normal reaction is always equal and opposite to mg. So if you say that Fn is equal to mg, so this equation Fs is equal to mu s, here we will say Fs is equal to mu s mg. Now here I told you that I replace Fn by mg, because on a flat road, this is for flat road. If the road is not curved, not banked, flat but not banked, like it is not one side above the other, it's straight road like the normal road for flat surfaces. So for flat surfaces, Fn is equal to mg, we studied last time. Now what was the condition for a car to take a turn was that this Fs should be equal or greater than Fc. If you need, for example, last time we did an example that if centripetal force is required at 4,500 newtons, so if Ss is more than 4,500, so it will take a turn. If it is less than, it will skid off. So the condition for a car to take a turn is that Fs, the static friction, should be greater or at least equal to centripetal force. If it is equal to centripetal force, then the car can take the turn, otherwise it will not take the turn. If I ask you, this is y-axis and x-axis, this is a vector f which is making angle theta with x-axis. F has two components. Okay, can you tell me what are those components? Fx, and the second one
Fx
is
and Fy.
Fy. Very good.
Theta
When I
times F.
use the word component, component can be the projection of F. projection of f on x-axis and y-axis.
y-axis.
If
Yes.
you put a light from the top, there will be projection on this x-axis. So this projection on x-axis is called x component, and we derive it as, we write it as fx. Whereas when you put a light from this side, there is a projection on y-axis, and this projection will be equal to, you can say its altitude, like this one. So this will be fy. So value of fx, you were going to tell me, please.
Yes. Cosine theta times f.
Yes, fx is equal to f cosine theta. We found this value by cosine theta, and fy is equal to f
F sine theta.
f sine theta. Now listen carefully. This is our previous knowledge. If someone didn't remember and you forgot this thing, I'm reminding this for you. From now onward, this is very important thing, that fx is horizontal component, or it is, if you consider that this is a right triangle. For example, if this is a right triangle in front of you, and in this right triangle you have been given by hypotenuse, and this hypotenuse has the value, let's say f, and angle with the base is theta. So the angle, this is the base, so this will be fx, and this will be fy. So what you say, it is the opposite, which is fy, opposite to theta, and adjacent to theta is always fx. Now
FX.
there is one more thing. Can I ask anyone
Oh,
else?
me.
Okay, you.
Yeah,
Can I ask you that there is a vector, like this is, this is the vector a.
yeah,
This is vector a. Okay.
yes,
Now this angle is theta. Can you please
yes.
tell me what, which one will be its x component and which one will be y component?
Uh, Adjacent.
Adjacent, which one? This one or this one?
Uh, FX.
No, this is a now. So you will
Yes,
say ax.
IAX. Yeah.
So this side, can you see my cursor, mouse cursor?
No, no, I can't.
Okay. Can you see now?
Yes, I can.
You can.
Yes, yes, I can.
Okay. This side is ax or ay?
This is AY.
Very good. Why? Why? Even though this is
Opposite.
horizontal, if you
Opposite.
see, but we have to check the angle. This is
Yes,
angle given, so this will become AY, and
opposite.
this will become AX. And
Adjacent.
if I want to you to find the value of AY, it will be A times sine theta, and this will be A time. The other one will be A
Uh,
time sine
Cosine.
theta.
Yes,
Okay. Now I got that you guys understood a bit about this thing.
yes.
Okay. Now ax, sorry, I didn't write it. A cosine theta. Okay. Now this is our previous knowledge about this. Secondly, one more thing I already discussed, that normal force is always parallel to this. Now I am getting back to the banking of road.
What can you repeat?
Banking. Can you see on your screen? I wrote it. It's like
Yes,
a bank.
yes, we can see.
Banking of road. Can
Mister,
you
I
tell
think I,
me?
Mister, I think I heard it before this time.
Okay, what do you mean by banking of road?
Well, I think when when the edges of the straight is tilted upward a bit.
Okay, very good, very good. If you have this road, let me try to make. Uh, this is a road. This road is a flat road. This is a flat road. In this side, edge number one. This is first edge, and this is the second edge of the road. Both are, one and two are at same level.
Yes.
Are at same level. And when this is at same level, if you are driving a car on it, as I tried to draw it previously above, so if this is the car, you are trying to drive away from me. So this is your car that you are driving, and these are the wheels of the car. So at the flat surface, I told you there are two forces acting on it. The first force is its weight
The
acting
gravity,
downward,
its
and the
energy,
second force is the normal
and
reaction of
normal
the
force.
road, and it is upward. And if it is a curve, for example, the road is flat, but if it is a curve, there will be a third force. That third force will be towards
Static
the
friction.
center of the curve. If this is a flat curve, let me make it a flat curve. Curve mean car is going to take a turn. If it is a flat curve, there will be a third force which will be provided by the friction, and it will be centripetal force that will be at least equal to or less than static friction. Okay, when it will take a turn. But this is a flat curve or flat road. On the other hand, if we make our curve in this way, that this is the actual picture of the road that is flat, but what I did, I lift one side a little bit up. So this is the first edge of the road, and this is the second edge of the road. The corner, left corner is down, right corner is up with some angle, let's say theta. So this kind of curve is called banked curve. What is called it? What you call it? Banked
Bank
curve.
curve.
So what is this banked curve? That one side is above the other. So you can say one end of the road, one end, one end, which one? One end number two is above the other. What is that
Yes,
edge? One. And car is going to take a turn, a short turn. So the road which was going uniformly like this, when it is a turn, road becomes a little bit up. If it is straight here, it becomes like this. So road
yeah.
becomes one side uppish than the other side. So one side is uppish. Why? Because in this way, car already will be provided some centripetal force. When road is up, so car will feel a force toward the center of the curve. So
Yes.
that bank will provide this centripetal force even there is no friction. So in this case, if the curve is banked, one side is a little bit up, there will be a centripetal force provided by the banking angle. So that banking angle or banked curve will provide us more centripetal force even there is no friction. So why we make the curve banked? Because if there is less friction or we don't want friction to involve, just make a curve a little bit banked, so it will be a support. For example, if the cyclists are uh, uh, racing in a curved path, you can say when they are trying to, or motorbike, if you check the race of the
Yes, they will
motorbikes,
tilt.
you see when they take a turn, they put your leg down, they put their leg down and bend their bike,
Yes.
and even after this they still can skid if there is no banking. But if you see clearly, the road on the curve of the bike race is always the other side from where they are taking turn, a little bit lifted. So this lifted is called banking. So one end, like end number two, is above the other. So this is called bank curve. So what happens in the banking curve? That this is your same car that was on the flat road. So when you are on this car, this is your car, and you are taking a turn with the help of this car. So what will happen? Uh, there are few things that will remain same, and there might be a little bit change in few things. So this is your car. What was actually mass is always the gravitational pull. You know that mass and weight will always remain toward the center of the curve. So this is the direction of the weight. But normal reaction is reaction of the surface. So what is direction of the surface? If my hand is this, surface direction is like the direction of the pen. Pen is upward. But if I change my hand, look like this, where is the direction of the pen? Upward. Mass is or weight is downward. But if I lift my hand like this, the direction of the pen, the normal reaction of my hand is in this direction now. You understand? So what happens is the normal reaction of the curve now changes from straight to
curve
this.
with theta.
This will move here. Fn changes because this angle theta changes it. Now, if I put, if this is the angle theta, Fn is a vector. Ogi, Fn is a vector. It will have two components.
Yes.
Can you please tell me where might be their components direction? Quickly, please. I will just show you previously. I told you if theta is here, the component with the theta is x and opposite to theta is y. So this component with the theta,
Why? I think why?
so what we call it?
Component of
Component. If
y.
you see, if this component is here, this component is along the theta, so it will be Fn x.
Yes.
You understand or not? Look here. This is theta. This is fx. This is theta. This is fx. This is theta. This is x. So where is the theta? The component along the theta. And the opposite is, this direction is opposite. So this is fy. So fy you can draw here, or you can also draw it in this direction. Sorry, I just make it a little bit. This is
So,
this. Yes, please.
Okay.
and you can say that the normal force direction is perpendicular to the surface.
Yes. Okay, now Fn x is Fn cos theta. Fn y is Fn sin theta. Now there
Science.
are 2 minutes left. I just need to finish this thing. Now just tell me, if you look at the figure, this Fn cosine theta is now balanced by mg. So car is not moving up, not going down. Car is taking a turn because of this Fn sine theta. So when you have a banked curve, this Fn theta sine theta will provide you centripetal force. Now, when the road is banked, when the curve is banked, you don't need friction. So what I want to tell you, that whenever you have a road where it's very carpeted roads are there, so these may be slippery, that the tires between the car and road will not provide you the necessary friction. So what engineer do, they make the road or the curved bank. So because of this banging angle theta, the car will have a component Fn sine theta toward the center of the curve. So this Fn sine theta will provide the centripetal force. For now, tomorrow I will give you few question examples in which we will use this formula, that Fc will be equal to Fn sine theta. Centripetal force will be provided by Fn sine theta. Now keep it in your mind. Fn is the normal reaction and sine theta is its component along the direction of the centripetal force. For to travel with a speed v around a curve of radius r, determine a formula for the angle at which road should be banked so that no friction is required. This is very important line, that no friction is required. When we don't want friction required to make the car bank, we will have the centripetal force from the Fn sine theta according to the banking angle, as you can see in this figure, as I made this figure in front of you, this figure. So Fc will be provided by Fn sine theta. What was the second relation? Second relation here was that mg is equal to fn
Cosine.
cosine theta. Now they are asking us to find the angle. Let me try to find the angle. This is our first relation. In this relation, we need to find theta. FC, you know, equal to mv squared over r. Only one thing is unknown to us, Fn. Rest of the thing we have. We have Fc, we have theta, we can find sine, but we don't have Fn. To find the Fn, I will use the second relation. The second relation written to you is mg is equal to Fn cosine theta. If I need Fn, I will move cosine theta here. So it will become mg divided by cosine theta is equal to Fn. So I will substitute the value of Fn that I get from here. So this Fn value I will substitute here. So it will become mv square over r is equal to mg over cosine theta. Now mv square over r is sine theta over cosine theta. Here are two very important points that we need to keep it in our mind. What are those 2 points? The first point is this m and m can be cancelled. Secondly, sine theta over cosine theta. Any one of you remember what is sine theta over cosine theta? We studied in same
Tan.
chapter
Tan.
number 3 last year. Yes, sine theta over cosine theta is tan theta. How it comes? If you remember, sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. When you simplify it, opposite over hypotenuse times hypotenuse over adjacent. Because when you fraction over fraction, so when you multiply it, it will become reciprocal. A over h will change into h over a. So h cancel, it becomes O over a, opposite over adjacent. What is opposite over adjacent?
Tangent.
You remember SOHCAHTOA?
Yes.
Yes.
SOHCAHTOA. What was so? Sine theta is opposite over hypotenuse. Cosine theta
Adjacent.
adjacent over hypotenuse. Tan theta opposite over adjacent.
Opposite of
So opposite over adjacent
adjacent.
is tan. Okay, now I just prove it how to do it. Now this becomes v square over r is equal to g sine theta over cosine theta is tan theta. They need us to find theta, so g will go on the other side and it will be divided. So it will become v square over rg is equal to tan theta. So if you need to find theta is equal to tan on the other side will divide and become tan inverse over rg. This is the formula that actually is providing us the banking angle. I know this is something really difficult to adjust and absorb when you are deriving the formulas, but it is the question's demand, so we did it. Now this is the angle theta. Before I solve for the values, I will just give you one very important thing. When engineers are making the curves of the road, they make the banking of the curve. For example, this is the flat road and they make the road like this. So this angle theta, they think according to this formula number 2. Why? Because in this formula, r is the radius that the car will take a turn, the curve, g is constant 9.8. They need to think of velocity, that if the car will move with, let's say, 50 km per hour, so how much should be angle? If car will move 70 km per hour, so whenever you go to the main roads and there will be a signboard written like in a circle that maximum speed limit is 70, maximum speed limit is 40 for this curve. 40 or 70 or 50 is written before the curve. What does it mean? If your speed is 50 or less than 50, your car will take a turn easily without skidding. But if you make your speed more than the assigned value, then the angle of the road bank is not seeing that one, so your car will skid. So this formula is actually helping us to develop the road. Now, as you said, I'm going to move to second part of the question. What is the angle now? They are asking for the angle for the road which has the radius of 50 meter and speed of designing is 50 kilometer per hour. Now in part B, they gave us two things. What are those two things? They said that we need to find theta, first of all, but the radius is 50 meter and the road is designed for the speed of 50 kilometer per hour. Now, if the designing of road curve is 50 kilometer per hour speed, so how much should be the banking angle? How much the engineer should increase the uplift the one side toward the to provide the centripetal force? When we will use this one, this formula number 2, you can say theta is equal to tan inverse. Can you guys open your calculators? Tan
Yes, sir, I
inverse
got the
V
answer.
is, yes please.
50 squared.
No. This is kilometer per hour. First of all, convert into meter per second.
So 5,000.
No. When you convert in meter per second,
Times
multiply by
3.6.
1000 divided by 3006, or simply is, as you said, divide by 3.6. So 50 divided by 3.6 will give you meter per second. How much is it?
13.888.
It's 13.8.
13.8 and last is 9.
It is
Yeah,
13.8.
13.8. 8, 9.
Okay, 13.888. I wrote 13.8 meter per second. Now, substitute
Second.
this value. V square is 13.89 square over G is as usual
9.8.
9.8. R is 50. Now, please simplify it and take the tan inverse. Before tan inverse, give me answer, please. Okay. First of all,
29.49.
if I'm not wrong, this answer is 3937.
21.49.
21.48
21.49.
degree. So make it two significant figure. When you make it two significant figure, it will be 21.22 because it's 21.49. So it is 21. It's less than 21.5. In book it is written 22, but I prefer 21. Why? Because this is 0.4. This is 0.49. So 0.49 is less than 0.5.
Civil engineers generally bank curves on road in a such manner that a car going around the curve at the recommended speed does not have to rely on friction between
Rely.
its tires. To rely on friction between its tires and the road surface in order to run the curve. Suppose that
That's
the
it.
radius.
Wait. These three lines are actually explaining what I was explaining in that equation. That civil engineer usually bank the road. Bank the curve mean to lift one side and keep the other side. Why they bank the curves on the road? That a car going around the curve at the recommended speed, the speed limit will be written on the signboard before the curve. So recommended speed does not have to rely on friction. That they make the bank curve, that no one will require the friction. So the curve is made already banked to provide the centripetal force. So now we have the centripetal force provided by the Fn sine theta, not from the mu s mg. Now read the question. Now the question is starting here. Yes, please.
Suppose that the radius of curvature of a given curve is r is equal to 60 meter,
Okay.
and that the recommended speed is v is equal to 40 kilometer per hour. At what
Okay. Now
angle?
you have recommended speed.
Mister, your voice, mister.
They are asking for the angle.
At what
Can I
angle
ask?
should the curve be banked?
Yes, please.
You're
Yes, Faisal.
Mister, you're lagging.
Mister, خلاص, it's okay. It's okay, mister.
Okay. Am I fine now?
Yes, mister. Yes, complete.
Yes,
Okay.
yes.
Mamoon.
Yes, mister.
Mamoon. Can I ask you? What was the formula? Do you remember? or let me write? Theta is equal
yes.
to tan inverse.
Tan inverse parenthesis.
Yes.
It's what is it? Speed or velocity?
Yes, v square over
GM.
r.
GR.
Okay. Okay. Before we substitute kilometer per hour, how will convert into meter per second?
Divide 3.6. It's 11.11.
Okay. What is your answer?
11.11.
Yes. So you will write 11.1 bar. Okay.
Yes.
So you can write it 11.1 bar meter per second because 1 it continues. And on the calculator, don't if you are able to see my calculator, don't need to remove this. Keep it written. Okay, don't erase it because this will help to give you the accurate answer. Now, I will substitute the values, Mamoon. You have to solve with me.
Yes.
Theta is equal to tan inverse 1.11111, sorry, 11.1 bar squared over
over
G
9.8 multiply 60.
60. Now, please help me out.
I got the
First
answer.
of all, before tan inverse, what is the answer?
Before tan inverse, 1 second.
Yes, I will just take the square directly of the. I didn't skip because I wanted it in that way. Now I will divide by
3.
Mister, I did it all. I don't know before tan inverse. So.
And Mr. J is represent.
Okay, keep it with you then.
0.209.
Yes, it is 0.2099 when you take the tan inverse.
When I take it, it will be 11.8.
No, before rounding off.
11.83.
Okay, when you take it is 11.83 degree. But now, if you make it in two significant figure, how much you will write?
And 1 or 2, 11.8.
12.
Right?
12.
It will be 12 because it is 83. 83 is more than 50.
Okay.
Yes,
A curve of
just read it
radius
quickly.
70 meters is banked at a 15 angle. At what speed can a car take the curve without assistance from friction? Answer is 14 meters per second.
Okay, whenever this is written without assistance of friction, then you can use that formula. What was that formula? Tan theta is equal to v square over gr. But in this question, we need to find v, not theta. So you will move gr on the other side. It will become gr times tan is equal to v square. So what will be the value of v? What will be the value of v? We will take under square root.
You mean
So it will
the
be
value
square
of V?
root of gr times tan theta. Okay, now just substitute the values, please. 9.8. Use your calculator quickly and give me the answer. R is 70.
Okay.
Tan 15 degree. Do it all together and give me the final answer, please. 13.55. Okay, 13.55.
Sir, how?
Yes,
How you
please.
square root? So the answer is 13.55.
So 13.55 meter per second.
Yeah.
Yes.
13.55.
Ahmed, what will be your final answer?
Yeah, my final answer is
Final, round it off.
14.
14 meter per second. Okay, thank you.